Hello everyone, it's Calder from 19. Today is day 64 in my challenge day. And I'm going to do set up some storage buffer, no storage image for ray tracing output today. And I want to finish it as soon as possible because I want to proceed with more some ray tracing specific logics like um, implementation in the shader language, not about the setting all the things that I need to going further. So, so um, okay, this that is what I'm going to do today. So let's start. Oh, top tracing. Okay, I found that there are some few things that I need to add to use storage buffer and the storage image in the dual frame logics. So that is the current implementation. I only have, where is it? If you see this info.cpp, my swap chain image only have transfer source bit and transfer no image usage color attachment bit in the image usage, but I'm transitioning from source stage, which is VK image layout undefined, to the VK image layout transfer destination optimal. So I need to add because I want the transition uh, transfer task optimal is the current stage that I want to use for the swap chain image. So it should have some proper flags inside the image usage. So that's what I have to do. I think those Chronos groups Vulkan samples use some abstraction uh, as they have a lot of examples and samples that based on some base class to provide some extendability to whenever they develop a new samples, they are using this base class by extended or implemented. So they don't set some specific the sample specific flags in the API samples, but they have in their some specific samples they are using some update flag or some update functions by define some interface in advance. But I only have just one application, so I'm going to add just directly in this image info. Start here to VK image uses transfer source speed, and I'm going to add that speed here. Uh, okay, this is fine. No build error. Let's read it. No error. Okay. By the way, this blue color means that I just changed the clear colors or just variation. Okay, this works fine. Silver color attachment clear. And let's get into the render pass. This commented part is just for multi-sampling. So let's just remove right now. Okay, so here's the thing. So far in my implementation, I just cle clear every color attachment in the third frame because I just render directly to the swap chain and the presentation. But now I want to use storage image first for the ray tracing output, and I want to copy from storage buffer data to the swap chain image, and after then swap chain image going to the presentation source. So if I just clear that about the color, if I just clear color attachment before I'm copying from storage image to swap chain image, will be a problem. So I need to set another flag for the color attachment, which is the load flag. This is fine. Okay. And operation for store is a store. The layout. Initial layout is VK image layout present present source key issue. Samples can keep the color attachment contents if they have previously written to the swap chain images. So these two changes in these color attachment flags for the load operation and initial layout means that uh, this ray tracing application can keep the color attachment contents if they have previously written to the swap chain images. So that is exactly what I want in my graphics pipeline. Okay, fine. Store operation, load operation, layout. Store clear, don't care. But there is no changes in the depth attachment. Okay. Collection optimers, depth attachment optimer. Fine point is still graphics pipeline. One color reference. The other things. Okay, let's just add for although these all the specification is default but has a default value, but just let's be explicit, like vocal weight. Is this all fine? Okay, I also updated the render paths properly. What I should do next time with the ray tracing pipeline properties, which we will later on this sample. I already said that, and I already created the. I already get acceleration structure features and ray tracing pipeline device. By the way, let's check. You get inside device features too, and the buffer device address features and acceleration structure and ray tracing pipeline features are enabled. So it's okay. And next, the key structure type Discord device features too, and the wiki gap Discord device features too. Mhm. And they create a storage image, create a scene, different buffer, trigger binding pipeline. Okay. Now let's try to use this. Let's uncomment these parts. So, so if I just recap this part quickly, mm, we first prepare current swap chain image for transfer destination by setting a proper image memory barrier for this swap chain. So the destination layout that is the current layout that I want to everything is finished before reaches this stage. So the source stage is undefined because we it's just start of rendering. So this is kind of pseudo state that we want, and we want to set some of image barrier for the transfer destination optimer on the swap chain image. And then we need to prepare ray tracing output image for transfer source. And this is just exactly opposite way of uh, exactly the just right before stage of this transition image layout transfer destination optimal for subchain image. So in this case, the image layout is general because I set image usage as a uh, image layout as a general for the swap chain, storage image. So we need to transition from the general layout to transfer source optimal, and the and the do actual copy, and then just uh, recover the initial layouts for each transition layout, uh, swap chain images layout, the storage images layout. Yeah, that's build. Right, right. Okay, I think finally I did it. It's fine. And no validation layer errors. Let's put some logs in here. If def and debug. How I did it right now. If def if and def and if okay log storage is recreated. Buffer is your uniform buffers. Is your descriptor set layout. Sync objects. The reason that I put every log bottom of the destructor because there some history error can happen before these logs. So it'll it'll be quite a wheel that if we get the log print log above these destroyers while it has some error while it destroying the resource. So to make the every cases valid, that I think is uh, reasonable to set to place all the logs at the bottom of this destructor after every destroy calling the destroyers uh, when they doesn't have any errors or exceptions. Okay. Now it's time to create descriptor set for uh, ray tracing pipeline to access for the ray heat in any shader. We need to access in some their resource, and for that, we need a descriptor as an interface of accessing the resources. And I set it. Now it's time to create actual pipeline. For that, let's just inspect whether I set the proper flags for texture or not. I didn't set here descriptor. So I said for textures, shader stage closest hit beat KHR. And this is the same. Yeah. Combined image sampler, fragment beat. And for the vertex with the VK shader stage ray gen beat KHR. And where's the uniform buffer? Buffer. Okay, pretty fine. Now let's try creating the descriptor. So originally the buffers, uniform buffers and textures, uh, and the buffers contain the vertices and indices were only used by rasterization pipeline. But we are going to using in the ray tracing. No, so we want. I've just used them in the ray rasterization pipeline, but I want to use it in the ray tracing pipeline either. So we need to set some proper flags for the vertex buffer and index buffer. But I think I already did it. And, shit. Registration flags. That's what I did. Just some videos in the last week because I already encountered error in the validation layer. This is fine. Each object was constructed with a buffer of vertices and necessary materials. Therefore, the scene. By the way, my current the Viking Loom object model doesn't have any material, so I didn't set any material color buffer or material index buffer for it. So we have access to all the data of the scene where interesting. Okay, and the last additional required implementation in the descriptor set implementation. So we need to update the descriptor properly whenever there is some contents changes in the restoration pipeline. Like if we resize the uh, if we resize the size of the screen, uh, which is a window, like GLFW or SDL, um, the actual resolution of the swap chain images and the frame buffers, also the textures, all of the things related to the window size or changes. So we need to change the descriptor set either for the resources or change it by the resizing. The update is performed on new master tool. But these also I already implemented in the graphics pipeline. If you see that, create storage image. We recreate a storage image. Then let's uncommented parts. From the ray tracer global service, we call that the updated descriptor image writes for updates. If we go to definition of that, you see it calls the write image to descriptor set with the storage image view. If we can now handle is about image sampler because we don't have a sampler for the storage buffer as I mentioned in the last video. And we have wiki image layout general for the layouts that we want for the storage image. The binding point is our image is a string, and we get descriptor type storage image, update data set, descriptor set. And what is changes in this recreate storage image that I can show that see in the create storage image. When we create a new storage image in the recreate storage image function, I get the new extent after the swap chain recreated. So this extent is exactly, definitely, no, trivially different things in the previous storage images extent. So that's why we recreate the storage image again when there is a resizing windows. Let's see the descriptor. I think I'm managing the resource history related to descriptor in the descriptor manager. So let me see first. Okay, as you can see, descriptor pool and descriptor pool is all managed in the one class, so it's okay that I don't need to destroy it in the ray tracing ray tracer. So let's just look for acceleration structure destroyer. So debug. Okay, load. Then create ray tracing descriptor set. Finally, so initialize ray tracing descriptor set. Please not really. Uh, okay. I can't initialize inside here. Create a storage image. Okay, let's add some line after that. Initialize. What's the matter? It's violation. acceleration structure, um, or image sampler, no, storage image. Okay. Hmm. There is some problem inside here. Binding is duplicate at p binding all conspect states. So there is some build error when we update the descriptor set. Let's figure out what is this error from. So it says that the binding is duplicate at p binding 2. Okay. Let's go to cell layout binding members of the element p binding arrays have different values. So computer doesn't say any, computer doesn't lie. Can maybe I said different, same duplicate out here. Let's break these points. Layout info, related bindings. Two different bind. What is that? Binding two, binding two. What's- Why the binding point is same? Okay, this was a problem. So this should be out image, not TLAS. If we break this point again, still there. Pnex chain includes a structure with unknown wiki structure type. Is based on valid usage version competitor. Okay, right, descriptor, set acceleration structure, THR, can I make this as a shared pointer? Let's try it out. Because this is not problem issue. I write descriptor set, sure, it's fine. Acceleration structure count is Okay, I think I need to. Oh, what is that? Okay, I think I need to figure out why this error comes out after finishing this recording. And I'm sure that I finally can create a ray tracing pipeline next videos. And I'm really interested in show you guys about the actual ray tracing logic to handle in the Vulkan API. So this is all for today's recording. And as always, thanks for watching. Bye bye.